The implications of the quantum revolution extend directly into the realm of tactical defense and the concept of quantum stealth. For the last 30 years, military technology has been defined by the ghost in the machine, the ability to use geometry and radar-absorbent materials to hide billion-dollar assets from classical radio waves. But the era of the ghost is coming to a close because the rules of the game have changed from hiding a shape to hiding an interaction. Classical radar is a flashlight in a dark room. It requires a reflection to see. If you paint an object black and angle its surfaces, the light never bounces back to the source and the object remains invisible. Quantum radar, however, uses entanglement. By sending one half of an entangled photon pair into the sky and keeping the other in the lab, a sensor can detect an aircraft simply by noticing that the internal photon's state has changed. You cannot absorb a quantum interaction. The moment a stealth jet touches that signal photon, the entanglement breaks, and the ghost is revealed. This level of transparency reaches deep into the oceans and underground through the use of superconducting quantum interference devices, or SQUIDs. These sensors are so sensitive they can detect magnetic field fluctuations as small as 10 to the power of negative 15 Tesla, essentially the magnetic wake of a human heartbeat from miles away, or the current flowing through a single wire inside a concrete bunker. For a submarine, the massive hunk of metal moving through the Earth's magnetic field creates a disturbance that these quantum sensors can track with high precision, making the concept of a silent service obsolete. We are moving toward a battlefield that is mathematically transparent, where the high ground is no longer a hill or an orbit, but the subatomic level. The first nations to master this quantum overmatch will see the world in high definition, while their adversaries are still squinting in the dark. This shift represents a total collapse of traditional strategic deterrence. If you cannot hide your assets, you cannot protect them. The stealth era of the F-117 and the B-2 was based on the assumption that the observer was limited by the speed of light and the reflectivity of surfaces. But in a quantum-illuminated world, the observer is limited only by the laws of entanglement. This means that secret movements of troop carriers, the positioning of nuclear submarines, and even the internal workings of a secure facility are now visible to those with the right sensors. For an engineer in the defense space, the challenge is no longer how do we hide, but how do we survive being seen. We are seeing the rise of quantum countermeasures, systems designed to flood the environment with fake entanglement or to scramble the phase coherence of enemy sensors. Furthermore, this transparency extends to the digital realm. Quantum sensors don't just see metal, they see information. Every electronic device emits a tiny electromagnetic signature. With quantum-enhanced signal processing, we can reconstruct the data on a screen or the keystrokes on a keyboard from across the street simply by measuring the quantum fluctuations in the local field. The air gap that used to protect our most secure systems is being bridged by the subatomic reality of the universe. This is the new great game. It is a race to build the sensors that see everything, and the networks that can withstand that total visibility. We are moving into a world where security is no longer about walls and paint, but about the integrity of the wave function. The veteran and the hardware engineer alike must realize that the battlefield of the 2030s is an entangled one. To win, you must own the subatomic architecture. You must understand that in the quantum era, the most dangerous weapon is not the missile that hits you, but the sensor that saw you coming from the moment you left the hangar.